Okay, this is the same problem that we just finished. This time I'm going to use tangent normal. Watch the other video first. It talks about whether or not you need a free body diagram. It talks about the degree of freedom, all of those things. So we've gotten to the point where we know we need a free body diagram. We draw the free body diagram. It's exactly the same way as it was before. After you have these three forces, the spring force, the normal force, and the weight, just like before. Nothing is different. After you draw the free body diagram, you ask yourself what direction should you sum forces. You should always sum forces that make the acceleration easy. In this case, it's obviously not x and y, but maybe it's tangent normal, maybe it's r theta. You really can't tell the difference because it doesn't talk about speeds. There's some r's, there's some thetas. That's why I chose r and theta, but I'm going to try tangent normal and see how far I go. All right, once I decide I'm going to use tangent normal, I draw in the directions. Here's the direction. I've got the tangent direction is always tangent to the path. You do that one first. Second one is you then draw the normal direction. Normal is always inward. You have no choice about it. It must be inward. So there's my tangent and my normal. Next thing I do is I write the equations for the tangent direction. Here's the equations for the tangent direction. So you're going to look for the blue forces that have a component that's pointed in this direction right here. The only one is the gravity. So you have mg sine of 60, and it's positive because the mg is pulling in the same direction as the t. It's not trying to slow it down, it's trying to speed it up. And that's equal to the mass times acceleration in the tangent direction. That's the equation for tangent acceleration. Then I also sum forces in the normal. You have a part of the gravity, and you also have the spring. So you add those two together. They're both positive because they're both pulling inward. And those are equal to the mass times acceleration in the normal direction. This is the acceleration in the normal direction. Raise the curvature is 2. That's why you have a 2 there. Okay. Now, I have, if you circle the unknowns, you have v dot, you've got v, and you got s. 3 unknowns and only 2 equations. Can you solve that? No, you need another equation. Why not look for a free body diagram? Same reason as in the r and theta. The v dot is a motion, v is a motion, s is a position. So all of those things are not forces. They are not force unknowns. You have too many unknown motions. Why? Because it's 1 degree of freedom. You should only have one of them. You've got 3. So you need to relate them together. All right? That's what I'm looking for. I need to relate v dot and v. Okay, so here we go. I take the top equation, I solve for v dot. Okay, once I have v dot, I want to integrate v dot and get v, because dv dt is v dot, right? Simple relationship. All right, can you integrate this equation, this equation right here? Can you integrate that? No, you cannot. Why? Because it's not always 60 degrees. So be careful. This is the same thing that happened before, okay? Well, what is that angle if it's not always 60? Well, what is it? It's always theta, okay? So you put in a theta. Now, can you integrate this one? Yes. Why? Because everything is general terms, and yeah, you can integrate it. Can you separate it? Because that's the only thing we know now. Well, we better be able to, or we can't solve it. Okay, so here's what I'm going to do. I'm looking for a way of separating the variables. I've got v dot, and theta. So I start with this one, dv dt, that's v dot. And that equals, I'm going to multiply by 1. The reason I use d theta is because I've got theta over here. I want to use thetas and v's. So I write d theta, and then I switch the bottoms, just reverse them. So I get dv d theta dt. All right, so if you think about it, what is d theta dt? D theta dt is the velocity, right? How do you know? Well, there's a couple of ways to know it. If you think about r theta equations, velocity in r theta is this equation right here. It's r dot nr plus r theta. That's velocity. That's the equation for the velocity in using r and theta. This direction right here is the same direction as the nt. All right? So what is the velocity? The velocity is equal to r theta dot. Okay? Or if you say, no, I don't buy that, right? See, that's what I'm doing here. V is equal to r theta dot. V dt equals this, so V is equal to r theta dot. Or if you say, no, I don't buy that, or I don't get it, okay, d theta dt is, there's an arc length, L, shown right here. The distance that the thing moves, right, is equal to the arc length, the radius times the angle, r theta, that's the arc length, okay? Take a derivative of that. dl dt is equal to r's constant, d theta dt. So what's the relationship between d theta dt and L? dl dt, that's the speed. It's the change in distance per time. That's speed. So speed is equal to r theta d theta dt. Same thing I have over here. Okay? So what I'm going to do is I'm going to take this equation and I say, what is d theta dt? D theta dt is equal to v divided by r, right there. Okay, so this would be dv d theta times d theta dt, v over 2. Okay, so this is a little bit more sophisticated, but I've just beat on it with a big stick until I get the thing the way I want. Now, can you separate these variables? Well, yes. Okay, so here, dv dt, v dot, right, from up here, v dot equals this term right here, equals dv d theta, v over 2. Dv dt is, from this equation right here, dv dt equals g sine theta. Okay, so now let's focus on this equation right here, this black one. Can you separate these variables? Yes, I'm going to leave the v dv on the left. I'm going to take the d theta, the 2 and the d theta to the right. So v dv equals, there's your 2, g sine theta d theta. Okay, they're separated. Now you're going to integrate them on the left-hand side, easy integral. Right-hand side, not too bad either. Don't forget the c. At how do you find the c? At you got to give me a theta and a v. Okay, so when theta equals 0, v is equal to 0. So you find out that c is equal to 2g. So you plug it in. 1/2 v squared equals minus 2g cosine. Now I'm going to put 60 because that's when I want the v, plus c. c is equal to 2g, right? Right, so v squared is equal to 2g. What am I going to do with that? I'm going to go get my blue equation, my second equation. This one, mg cosine. I'm just going to copy it down here. I just copied it down. That's all I did. And now I'm going to plug in what I have for v squared. So I'll plug in the v squared. So mg cosine of 60 is 1/2 mg over 2 plus ks equals m, this is v squared, over 2. Okay, solve this, right? So ks is equal to 2 over 2, mg minus half of an mg. So the the stretch is equal to, and just 1/2 mg divided by k. mg is equal to 2, so 2 over 2, that's 1 over k. So s is equal to, k is equal to 2, so s is equal to 1/2. Find the free length. The free length is, the stretch is equal to 2, because that's how long it is, minus the free length. The free length is 1.5. That's exactly what I got last time using polar coordinates. Okay, so you could do it with either one.